Hello everyone, welcome to Quanta. My name is Nathan. I'm sure all of you are doing great. Guys, it's the first video of ratio and proportion, which is one of the most important chapter, can be asked in QD section. Today we'll be discussing some basics of the ratios with some important applications. Alright, so let's just start this chapter. So guys, first we'll understand what ratio is, why is it being calculated, and how is it being calculated, right? So to explain this, I would like to take an example of, let's say, a classroom, right? Let's say there is a classroom in which the total number of students is given to us, let's say 50, right? And in which the number of boys are given to us, let's say 20, and the number of girls are given to us as 30, right? Now the next thing, guys, we need to find the ratio of the boys and girls. So let me tell you first thing, the ratio is something which is used to compare the different identities. For example, here if you have to compare the number of the boys and girls in the classroom, so we'll be using the ratios. How? Okay, we'll say the boys is to girls, this is the sign of the ratio actually. So boys are 20 and girls are here 30, alright. So if you simplify this, we'll get this as 2:3. So this is how we can find the ratio of different identities, alright. Now guys, one more thing, in general the ratio is written as A:B, alright. So what is A and what is B in this? So A is basically called antecedent, right, and B is called, we can say, consequent, alright. So you must be thinking that why we are discussing this. So guys, what actually happens that in the questions, usually the questions asked in the word problem, so maybe they ask in the end that find the antecedent of this particular ratio, or maybe consequent or a particular ratio. So we should know that A in the ratio is called antecedent and B is called the consequent. Alright, now there is one more doubt which often comes in the mind of students, that what is fraction then, right? If this is ratio, then what is fraction? First thing, guys, fraction is something which is not used to compare. Fraction is something which is used to find the part of that particular identity as a whole group. For example, if we have to find the fraction of boys in this example, right, as we already calculated the ratios, if we calculate the fraction of the boys, so we'll say what? The number of boys is 20 and the total students in the class is 50. So we can say the fraction of the boys in the class is 2/5, alright. That means you can also say that if in the class there are 5 students, then the boys are 2. We can actually say like this as well. Similarly, if you have to find the fraction of the girls, so we'll say what? The fraction of the girls is the number of the girls with respect to the total students, right, which you can also say as 3/5 in the end. So guys, this is how we can calculate the fraction as well, and this is also the difference of the ratios and the fraction. Now if I put some example to find that what will be the ratio of these different identities. So guys, example number 1, if I put that what is the ratio of, let's say, 2 kgs and 500 grams, alright. So guys, 2 kgs, if you convert into the grams, that will actually come as 2000 grams, very simple. And the second number is given to us 500 grams. So this ratio will be obviously 4:1, because gram and gram will get cancelled out, right? Okay, similarly, if I put another example, let's say the another example is that we have to compare, let's say, 5 kilometers and let's say 20 liters. So what is the ratio of them? So some of the students might be saying the ratio is 1:4, 5:20 is 1:4, but guys, the answer of this example is cannot be determined. Why? See guys, I told you in the beginning that the ratio is something which is used to compare, right? And look at these numbers, this is 5 and 20, but look at the units as well. This is 5 kilometer, and kilometer actually is a unit of the length, right? On the other hand, that liter is the unit of the volume. So guys, you think about it, how can we compare the length and volume, right? This is not able to, this is something which we cannot do that. We cannot compare length with the volume, so that's why the ratio of something is which we can say that it cannot be determined. Simple. Alright, now we'll be understanding some basic questions of ratios, and by the help of those questions I will also tell you that how we can use some shortcuts, or you can say we'll be also learning some logics with the help of those questions. Alright, so let me represent the very first question, and this is one of the easiest as well, but still we'll be learning it because I want to tell you some new methods to solve these questions, right? So question number 1 says that out of 240 students in a class, the ratio of boys is given 3:5. One is find the number of boys and the girls. In fact, I have already given such kind of question, but in that question we will be finding the ratio, and here the ratio is given and we need to find the number of boys and the number of girls. Alright, so guys, these kind of questions were in school as well, in the primary classes. So in school, how do we used to solve these questions? We used to find the, fraction of boys and girls with the help of the ratio. For example, the ratio here is given that 3:5, right? The ratio of boys and girls is 3:5. So what will be the fractional part of the boys? We can say what fractional part of boys is like 3 upon 3 plus 5. How did we do that? The number representing boys is 3, representing girls is 5. So for boys, we wrote 3 first, and in denominator is 3 plus 5. Simple. Similarly, if you have to find the fraction of the girls, so same way, the number representing girls is 5 divided by, we can say 3 plus 5, right? Now, if you have to find the number of boys and girls, we obviously have to multiply with the total number of students as well, right? Now, the total number of students in the class we have is 240. So we'll multiply with 240 with the fractional part of boys and girls just to get the number of boys and girls. Simple as that, right? Now, what we can say about it, so this will be, 3 by 8 into 240. And the number of girls is 5 by 8 into 240, right? Now, 240 by 8, we all know is nothing but 30, all right? Now, 30 into 3 in first case is 90, and in the second case, number of girls, 5 into 30 is 150. That's it. So this is how we can find the number of boys and girls in this problem. Very simple. That was a method we use, usually in this school. Now, I would like to tell you a few more methods, right? So guys, here, since the ratio is given 3:5, we can assume the boys and girls with the help of the ratio. We can say what the number of boys are, let's say 3x, and number of girls, let us say, 5x with the help of that ratio, okay? Now, the total students we know is 240, which is nothing but the sum of, boys and girls. So we can say b plus g is 240, which is given to us, putting the values of boys and girls in terms of x. So boys are 3x, and the girls are, 5x. So that has to be 240. That means 8x is 240 as well, and that means the value of x has to be, 30 in the end, right? Now guys, if the value of x is 30, we can say boys are how many? Because boys we assumed is 3x, x is 30, so 3 into 30 has to be obviously 90. Very simple as that. Similarly, the number of girls, which we know is 5x as the assumption, putting x equal to 30, so 5 into 30 must be 150. Simple as that. So guys, this is how, we can find the number of boys and number of girls, right? So this is a second method. Now, I would like to tell you one more method, which I would suggest you to use, the most in a preparation, because that method can save a lot of time of us, right? What is the method? Okay, again, let's say the boys and girls ratio is 3:5, right? So guys, in this method, we'll be again assuming the number of boys and girls, and this method is very much similar to the second method, but in this method we'll not be writing the variables. That's the only thing which you can, which you can do to save our time, right? How guys? See, the ratio is given 3:5. So with the help of the ratios, okay, we'll assume the number of boys as 3, okay, and we'll assume the number of girls as 5 only, right? Here we had assumed 3x and 5x, but now we'll be assuming only 3 and only 5, okay? So what will happen with the help of this? So guys, the total students given to us 240, which is again, the sum of the number of boys and the number of girls, right? Okay, and with the assumption, what is being the total number of students? See, boys we have assumed as 3 and girls we have assumed as 5. So total should be 8, right? 3 plus 5 is 8. But we just know that this is not real. This is actually the assumed data, right? The real data is what? The total student, the boys and girls sum is 240. So we can say the assumption, the assumption of the total number of students is 8. But then actual, the total number of students are 240. So we can say 8 of assumption is 240 of the real. That means 1 of the assumption is 30 of the real. Simple guys, right? 8 of the assumption is 240, so 1 should be obviously 30, right? Since 1 is 30, we can say 3 has to be how many? See, 1 is 30, so 3 has to be 90. Okay, similarly 1 is 30, so 5 has to be 150. So again, we got the number of boys and number of girls, right? And all the methods, obviously the answer is same, has to be same, right? So we have 3 methods, to solve this question. But I would suggest the third method the most, because once you get perfect in this method, then you will not have to write much to solve by the help of this method. It might take some time to, understand and learning how to execute this method. But once you learn about this, once you, comfortable in executing this, then trust me, this is one of the best methods, among the 3 methods given here, right? Okay, so this is the question number 1. Now I will be solving, the next question by the help of the last method the most, and obviously we're not forgetting these two methods. We'll use these methods as well. We can use them depend on the data of the question or maybe the condition of the questions, right? Okay, now let us try the second question. The second question, guys, says the ratio of the salaries of A and B is given to us 5:7, and the difference of the salaries is given as 3,000. Now we need to find the sum of the salaries. Okay, now again I'll be using that third method of the previous question, and I'll show you how that method can be used in solving challenging question, or you can say moderate questions as well. Okay, ratio of the salaries is A to B is 5:7. We know that the difference of the salaries is 3,000. So let's write like this. A to B is given to us how much? 5:7, right? So guys, let us assume the salary of A for a while is 5 and the salary of B for a while is 7. All right. Now we are given the difference of their salaries, right? Okay. Guys, difference in the assumption are how many? You can see that B's salary is more than A's, so the difference is 7 minus 5, which is 2, right? But this is something again, which we are writing the assumed number, right? But in the real, the difference is how many? Rupees 3,000, right? So we can say that 2 of the assumption is 3,000 of the real, right? 2 of the assumption is 3,000 of the real. So 1 of the assumption should be, we can say 1,500 of the real, all right? 2 is 3,000, 1 is 1,500. So 5 will be how many? So guys, if 1 is 1,500, then 5 will be 1,500 into 5, which you can say is 7,500, right? And 7 must be how many? Okay, again 1 is 1,500, so 7 must be, we can say 10,500, all right? Now the question is to find the sum of their salaries. So what will be the sum? We can write it here. A plus B, the salary of A comes to be 7,500 and the salary of B comes to be 10,500. We can add them and that will give us how many? That would be 18,000 actually, right? So we can also say we can find the sum of the salaries of A and B like this. But guys, in this particular question, luckily there is one more way which you can use, all right? What is that method? Let me write that here. Okay, the second method is what? Okay, I'll be using ratios and assumption in a similar manner, right? Let me write here the ratio of the salaries is 5:7, assuming again the salary of A as 5 and the salary of B as 7, all right? Now what is the difference of their salary? So difference we can say is 7 minus 5, which is equals to 2 on the assumed part obviously, and the real difference is given to us rupees 3,000, all right? Now we need to find what, guys? We need to find the sum of their salaries. So look at that. In the assumption, remember we had assumed salaries as 5 and 7. So what will be the sum of their salaries in assumption, right? 5 plus 7 is 12. Simple. So guys, you can say what? See, 2 of the assumption is 3,000 and we have to find 12 of the assumption is what number in the real, right? This is also, we can read this question in the end, right? So 2 is 3,000, so 12 will be how many? So guys, simply this you can say is getting 6 times. So this right side should also be getting 6 times. Simple unitary method, right? So 3,000 into 6 has to be nothing but 18,000. So this is how we can say that sum of their salaries must be rupees 18,000 by using this method. So in this method, we do not need to find the exact salaries of A and B. We can directly find the sum of their salaries by using the assume and the unitary method. Alright guys, so this is question number 2. But yes, if we had to find the individual salaries in this question, then obviously we have to do this. But luckily we had to find the sum of the salaries, so we did this method directly. Okay, guys, one more thing, we use this particular method of assuming the values by the help of the ratios, but we can do this only when the questions are of, you can say, sum or of differences, right? If the question based on multiplication, then we can use this, but with some you can say changes or some more conditions, which I'll be discussing very soon. All right. Okay, let's move to the question number 3 now. The question number 3 says that an amount of rupees 2,100 is to be divided among the 2 people in the ratio of this. Then how much salary does each get? Okay, similar question, like question number 1. But why did I give it to you? Because in this question, the ratio is given in the form of the fractions. Last time, the ratio was simply given in the natural numbers, but here, the ratio is given in the form of the fraction. That's why I give, a similar question one more time. Let's see how we can do that. The question says that an amount of rupees 2,100 is divided among the 2 people in the ratio of 1/2 is to 1/5. Then how much amount does each get? All right. So guys, first thing first, we'll do what? We'll try to simplify that ratio. That means here the terms are in fraction, but we will try to write them into the natural numbers. All right, how guys? See, the ratio is given to us how much? 1 upon 2 is to 1 upon 5. Okay, so we will try to write that ratio in the form of natural numbers, and that is something can be done in a lot of ways. All right, how? Okay, either you can take the LCM of the denominators and make it the denominator of both the terms, or we can do one more thing guys, is a very simple property of ratios, that if we multiply or divide the terms of the ratio by the same number, then ratio does not change, right? That means if you multiply these two terms with the same number, or if we divide these two terms with the same number, then the ratio does not change. Okay, so what we can do here, I'm going to multiply these two terms with such a number by which we get a natural number at both the places, and that number best can be the LCM of the denominators of these fractions. For example, here the fractions denominator are 2 and 5. If we take the LCM of 2 and 5, which is actually 10, right? So I'm going to multiply both of these terms with 10. Okay, so what would happen with this? First thing, these two terms will come in natural numbers, and ratio will obviously not change because we are multiplying with the same number, as I said. Okay, so 10 by 2 will be obviously 5, and 10 by 5 will be 2. So now the ratio of the amount which these two people are going to get should be 5:2, right? That is a simple form of the ratio. Now guys, I think this question is too easy for us. We just have to distribute rupees 2100 into two people, and the ratio of the amounts of them should be 5:2. Or we can say what? That we have to distribute 2100 rupees in the ratio of 5:2, right? Such a simple thing now. Okay, so let's say one part is 5 and second part is 2, with the help of the ratios. Okay, let's write over here, one part let's say is 5 and the second part is 2. Okay, so in that way the sum of their parts should be what? See guys, by the assumption we can say the sum of their parts is 5 plus 2, 7. All right, and in the real the sum of their parts is 2100 rupees, right? So 7 of the assumption is 2100 of the real. That means one of the assumptions should be 300 of the real. All right, okay, so 1 is 300, that means 5 has to be 1500. Okay, and 2 has to be 600. Simple. Okay, that's it. So guys, these two should be the part of the money which is being distributed into on two people. All right, so this is how we solve question number 3. Now let's move to question number 4, right? Let's see this question now. This question says guys that the ratio of the length and breadth of a rectangle is 3:4, and the area is given 1200 square meter. Find the length and breadth of the rectangle. All right, so this time the area is given and the ratio of length and breadth of a rectangle is given. All right, so length into breadth is how much? 3:4. Okay, and the area is given to us 1200. We need to find the length and breadth. Simple. All right guys, so again with the help of the ratio we can assume the length and breadth, right? So let us assume the length for a while as 3, okay, and let's assume breadth for a while as 4, right? And we all know the formula of area of a rectangle. That's one of the easiest formula. The area of the rectangle is length into breadth, right? Okay, so length is how much? Length is 3 and breadth is 4. Okay, and the area according to the assumption it should be 12. But guys, area in the real is how much? In the real area is 1200. So we can say 12 of the assumption is 1200 of the real. That means one of the assumption is 100. Okay, now if one is 100, we can say 3 has to be 300 and 4 has to be 400. Okay, so length is 300 and breadth is 400. Okay guys, let's cross check is it going correct or not. Okay, length is 300, breadth is 400. So what should be the area in that way? Length into breadth, 300 into 400, and that is obviously not 1200 guys. You can check it, right? This is in fact being how much? 12 and 4 zeros. That means 1,20,000, right? So guys, that means we have done something wrong here. Yes, actually we have done some mistake. Okay, if you remember what I told you that we can assume something like this in the cases of addition and subtraction. But here if you look at this, these two values are getting multiplied, right? So I told you that we can use these kind of assumption in multiplication questions as well, but with some with actually one more condition. What is that one more condition? Okay, let me discuss that now. Let's erase first of all of this because that's just not correct. right? But if you make just one change, this will be correct in these questions as well. All right, so what is that, guys? See, here we are multiplying two numbers, right? To get the area, we are multiplying two numbers. So whatever is coming in the end, 1 is equivalent to 100. We just have to do one thing. We have to find the square root of 100, power half, okay? That's it. This is the only next thing which you have to do, all right? Suppose we are multiplying three numbers here, right? Then we will have to do power 1 by 3. Suppose you are multiplying four numbers, then we have to do power 1 by 4. That's the only change we have to do, and then this will be, perfectly correct. All right. Let me show you. See, 1 is the square root of 100, and we all know the square root of 100 is actually 10. So we can say what? That 1 is not 100. 1 should be 10, in this particular question, because this is about multiplication. Okay, if 1 is being 10, then 3 must be what? If 1 is 10, then obviously, guys, 3 will be 30. And 1 is 10, then 4 will be obviously 40. And now if you want to cross check, you can do that. See, area is what? Length into breadth. Length is 30, breadth is 40, and that product is being 1200. And guys, this time, this is perfectly correct. That means the answer of the problem should be what? The length and breadth should be 3:4, right? And yes, the unit will be meters, all right? And guys, one more thing, in geometry, usually the length of the rectangle is greater than the breadth of the rectangle, but you can ignore this part for now, because we are not studying geometry right now. Okay, so that was question number 4. Now let's move to next question, right? Okay, now guys, we are, increasing the level a bit. This time they are saying that A is to B and B is to C are given, and we need to find A is to C, all right? So how we can do that? There are again a lot of ways of doing this, and I'll try to explain, all the possible ways. All right, first method, guys, since we know A is to B and B is to C, right? So first method which I'm going to tell you is something which you have to, you can say remember a little bit, all right? See, A is to B is given 3:4. Let me write it here. A is to B is 3:4, all right? And B is to C is what? B is to C is 6:5. So see what have I done here? I've written, the B of this and this, just one above each other, right? Above and below to each other. Simple. Why? Because they are same variable, right? And the coefficient of B here is 6. So and the coefficient of B in the first ratio is 4. So this 6 I'll be writing, just below that 4, okay? And 6:5. So this is first thing, the way of writing the things, all right? This is a way of writing this. If we have to find A is to C, we have to write like this, okay? Now again, next thing is what, guys? Final is that we have to find A is to B is to C, right? So what shall we be doing? See, we can say this is first column, this is the second column, and this is the third column. We can say that we have 3 columns over here, right? Now, but in these 3 columns, you know that this number is missing, right? And in this particular column, this number is missing, and that column is completed, right? So what can we do here? See, guys, this number is missing, so we'll be, taking the number which is adjacent to this, that means this one, and just, writing the same number. Like this is 4, so this should be 4 as well. Similarly, this number is missing, so the number adjacent to this is 6, and we'll be writing, the same number over here. Simple. So this is one thing we do. Okay, let me erase that thing. Okay, I hope you all understand that how did I, take that number. Now we'll be, multiplying the numbers in all the 3 columns. Simple, right? What shall we be doing? We'll be multiplying the numbers in the same column. For example, the first column 3 and 6. If you multiply 3 and 6 is 18, right? Second column 4 and 6. If you multiply, we get 24. The third column 4 and 5. If you multiply, then we get 20. Simple, guys, right? Now we have to, simplify this, because this is not written in the simplest form. If you simplify, we get what? See, we are dividing by 2, so this is 9, this is 12, and that gives us 10. So this is how, we got the value of A is to B is to C. But guys, the final question is to find A is to C, right? So what we can say about A is to C? Okay, so A we can say is 9, and C we can say is 10, right? We just missed out B, because the question is about A is to C. So guys, this is how, we can find the ratio of A and C in this particular method. All right, now let me tell you another method, right? The next method is more about the logics, right? This method, you saw that it was something where we have to, remember a few things, right? But this one is purely about the logic and concepts, right? In second method, see, guys, A is to B is given how much? A is to B is given 3:4, and B is to C is given how much? B is to C is given, we can say 6 is to 5. All right. Again, guys, we'll be using B. Why? Because B is, common in these two ratios. So we'll be using B for sure, right? B, you can say, is a bridge to find A is to C, right? Okay. Now, guys, here we can say what? The ratio is 3 is to 4, right? So we can say what? If A is 3, then B is 4, okay? If A is 3, B is 4. I'm not saying that A is 3 and B is 4. I'm saying if A is 3, then B is 4, right? In this one, we can say similarly, if B is 6, then C is 5. Okay, guys? I'm not saying B is 6 and C is 5. I'm saying if B is 6 and then C is 5. Now we can actually, equal the values of B because B is the common link, right? But guys, B is not same here. You can see that B here is 4 and here is 6. But we have to make them equal to find the value of A to C, or to find the relation between A and C. We have to make B equal, and that can be done. Remember, guys, I did not say that B is 4. I said that if A is 3, then B is 4, right? Okay, so to make them equal, right, we can do best thing is what? We can take a number which is the multiple of both 4 and 6. And the least, multiple of both 4 and 6, or you can say least common multiple of both 4 and 6, or you can say the LCM of 4 and 6 is actually 12, right? So let's make both of them as 12. How we can make both 12? Okay, very simple. If you have to make this 12, what shall we do? See, guys, this 4 is being multiplied by 3, so this number should also be multiplied by 3. Only then this ratio will be the same, right? So multiplying this by 3, that means this is also multiplied by 3, that means this must be, 9. Or you can say both of them has been multiplied by 3, all right? Okay, now the second method, here also we want to make B as 12, right? Make them both of them making equal to each other. Okay, now if here B is being 12, so 6 has been 12, that means multiplied by 2. So we have to multiply this by 2 as well to make the ratio equal, obviously to make the ratio same as 6 is to 5. Okay, multiplying this by 2, we'll say what? 5 into 2 is 10, all right? So now we can say B is 12 and A is 9 and C is being 10, that's it. Finally, we will get the value of, A is to B is to C. All right, let me write that here. Okay, finally we can say what, guys? A is to B is to C. A is being 9, all right? B is being 12, equal in both, yes. C is being 10. So again, we got the ratio of A is to B is to C, and you can match this. This actually being the same as we got in the first method, has to be same, right? Okay, and then we can say by the help of this, A is to C is how much? A is to C is obviously 9 is to 10 in the end. All right, so this is we get A is to C. Now, guys, one more method, okay? Right, in these two methods, guys, you must have observed one thing. The question is about A is to C, and we are finding A is to B is to C first, right? To calculate A is to C, we are finding A is to B is to C. So you know what? There is one method by which we can get A is to C directly without finding A is to B is to C. Let me show you how. Okay, guys, see, if you have to find A is to C, we can do what? We can actually multiply A upon B with B upon C, right? Okay, if you observe this, A upon B into B upon C, B got cancelled out, and what we are left with? We are left with A upon C, yes. So this is something, A is to C or A upon C we can get directly by multiplying these two ratios, okay. Let me write in the form of ratio, okay. We can say A is to B multiplied by B is to C, we can get A is to C, right? Okay, now changing the sides, we can say A is to C is equal to A is to B into B is to C, all right? Now let's write the value of these two ratios. A is to B we know is 3 is to 4, okay, and B is to C we know is how much? B is to C is given 6 is to 5. All right, if you have to simplify, let's write in the form of the fraction. This is 3 by 4, this is 6 by 5. You know that 4 and 6 have 2 in common, right? So we can cancel 4 and 6 a bit. All right, so 4 and 6 have 2 in common, right? So this is 2 2s are and this is 2 3s are. Now what we have after this, we can say 3 into 3 is 9 and 2 into 5 is 10. So guys, this is how also, we can say that A is to C is being 9 is to 10, right? And the same answer as we had got in the previous two methods. So guys, we have in all, 3 methods to solve this particular question. All right, now if guys, the question, if you have to find only A is to C, then yes, the third method is the best one, right? Because in this method, we are not finding A is to B is to C, right? And suppose we have to find A is to B is to C, then third method is not much helpful. Then I would say that the second method is the, better than the first one, okay? But the end choice is always yours. You can choose any method which you like the most. All right, guys. So this is how we discuss, question number 5. Now, guys, question number 6 is, you can say, the extension of question number 5. In question number 5, we had 2 ratios, in which in this question we have 3 ratios, like A is to B, B is to C, and C is to D, and we have to find A is to B is to C is to D. All right, so this time, we don't have to find A is to D or A is to C. We have to find the ratio of all these 4 terms, right? So we can use any of the first 2 methods which you use in the previous question number 5. Third method is obviously not much recommended, but we can use the first and the second method for sure. Let me show you both the methods to solve this. All right, okay, so let's write all the ratios in the similar way in the first method as we had done in the previous problem. So A is to B is, we know, 3 is to 5. All right, let's write like this. B is to C is 2 is to 3, right? B is written, below the value of B, which was coming in the ratio number 1, right? So 2 is to 3. Then we have C is to D, so C below C, all right? And the coefficient, or you can say number representing this ratio with C, is written below this, right? See, here is 3 and here is also 3. It's okay. Fine. So this is how we written all the 3 ratios, all right? Now we have to find A is to B is to C is to D, all right? Okay, guys, how we can do that? Let me show you. All right. So in this, question, you can see we have, 4 columns. In the last question, we had 3 columns, but now we have 4 columns. All right. Let's see what numbers we do not have. Okay, we do not have, you can say, this number. We also don't have this number, right? See, we have 4 columns, right, guys? Or let's, start column wise column, right? So in the first column, if you see which numbers we do not have, right? We don't have this number, and we also do not have this number. In second column, we don't have this number. In third column, we don't have this number. In fourth column, we do not have both of these numbers. So what do we do, guys? We have to, fill these numbers to, to operate the next process. So what do? We follow the same method which we followed in the last question. We'll take the adjacent number and just writing this here. For example, you see that, 5 is here, so we'll be writing 5 here. 5 is here, so we'll be writing 5 here as well, the adjacent number, simple. 2 is here, so adjacent number 2 will be written here. 3 is here, so again 3 will be written here. 3 is here, so 3 is here. 3 is here, so 3 is here. Now we got all the numbers, right, in all the columns. Now the next step is just to multiply the numbers in the same column, right? For example, the first column, guys, if you look at that, we have 3, 2, and 3, and the product of this should be what? 3 into 3 is 3 into 2 is 6, 6 into 3 is 18, all right? Second column, 5 into 2 into 3, we can say that is 30. Third column, 5 into 3 into 3, 5 into 3, 15, 15 into 3 is 45, okay? Fourth column, 5 into 3 is 15, 15 further is 60, all right? So this is how, we got, you can say, the 4 numbers, right? But yes, these are not in the simplest form, but that is something which you can do, right? So guys, what we can do about this, simplest form of this, they all are actually divisible by 3, we can say that. So this is 6, this is 10, this is 15, and this is 20. So this we can say is ratio of A is to B is to C. If you want, you can cross check as well that whether it is justifying, the given ratios of A, B, C, D or not. So guys, A is to B is 3 is to 5. You can see A is to B is actually being 3 is to 5, 6 is to 10 is 3 is to 5. B is to C is given 2 is to 3. So 10 is to 15 is also, 2 is to 3, same as given. C is to D is 3 is to 4. So is it 3 is to 4? Actually, yes. 15 is to 20 is also 3 is to 4. So guys, we can say what? That in the end, this is the final ratio of A, B, C, D, all right? Okay, moving ahead. Now, I would like to tell you the second method, which is, more about the concepts, right? Okay, let's write all the ratios one by one. A is to B is 3 is to 5, B is to C is 2 is to 3, and in the end, C is to D is how much? That is 3 is to 4. All right. So first thing, that by the help of A is to B and B is to C, we'll try to find A is to B is to C. All right, guys. Okay, just a second. Let me write that 3 is to 4. Okay. What shall we do? By the help of A is to B and B is to C, we'll try to find A is to B is to C. All right. So how do we do that? Again, the same logic which we applied in the last question. Okay, see guys, let's assume A is 3 here with the help of the ratio and B is 5. Here, let's assume B is 2 and C is 3, right? Now, we know that B is common here, so we'll be taking the same numbers to B. B is 5 here and here is 2. The LCM of 5 and 2 is 10. So we'll make B as 10 in both the ratios, right, both the assumptions. If this is 10, right, if B is 10 here multiplied by 2, A will be 6 because both are being multiplied by 2. Similarly, in this ratio, we'll be making B as 10. So this is being multiplied by 5. That means 3 will be multiplied by 5 as well, you know, the value of C, and that will be 15, okay? So after this, we can say what? We can get the value of A's to B's to C, right? What is that, guys? See, A is being 6, all right? B is being 10, and C has become 15 over here, right? So we got the ratio of A, B, C, but the actual question has not been solved yet, right? So now, guys, again, you know, we'll be using A's to B's to C and C's to D to get the ratio of A's to B's to C's to D. Yeah. In this method, you can say yes, the only problem is that we have to use the same method twice, and here we had to do it only once, right? Okay, but still I would prefer this method because this is more about the concepts, right? Okay, now guys, in these two ratios, C is common, you can see that, right? C is being 15 over here, and here C is being 3, okay? D will be 4, we can say that, all right? And A and B in the first ratio, we can say 6 and 10 by using that ratio, okay? C is the common link here in these two ratios. C here is 15, here is 3. So we'll try to make them equal. Okay, so luckily, you know, 15 being the multiple of 3, so we can say what? We'll take the multiple of 3 and 15 both, which will be 15 only because 15 is a multiple of 3. Okay, let's make C in both the ratios as 15. This is already 15, we just have to make this 15. To make this 15, we'll multiply by 5, and if C becomes 15, you know, multiplied by 5, D should also get multiplied by 5, and 4 into 5 should be 20, right? So finally, we can say what? That C is 15 in both of them, and A will be 6, B will be 10, and D will be 20. And finally, we can get the ratio of A, B, C, D in this method as well, all right? What we can say here, guys, after doing all of that, you know, A comes from the first ratio as 6, B comes from the first ratio as 10, C comes 15, which is common in the second ratio as well, but D is being 20 from the second ratio, and this, you know, is the ratio of A's to B's to C, D. A is the ratio of A, B, C, and D, which is same in the first method as well, and it had to be same, right? So guys, finally we found the ratio of A, B, C, D with both the methods, and yes, you can choose your method according to, you know, your comfort. Alright guys, so that was question number 6. Now let's move to question number 7. Okay, so we have done a lot of, you know, you can say simple question or moderate level questions, but we are doing, you know, simple question with 1 line or 2 lines, right? Now we'll be doing some word problems. You know why? Because in the end of the exam, right, they will be giving the question in the form of language, right? So it's very important to understand the language of the question and solving them. So that's why let's start with some word problems, all right? Question number 7, the question says that the ratio of the monthly salary of A, B, and C is 2:3:4, and the monthly salary of C is given is 5,000 more than the monthly salary of A. The final question is to find the annual salary of B. Alright guys, not very difficult actually. We are given what? We are given the ratio of the monthly salary of A, B, C as 2:3:4, right? Okay, and we are given that the salary of A is 5,000 more than the salary of A, all right? Salary of C is 5,000 rupees more than the salary of A, and we have to find the salary of B, but the annual salary, all right? And this is the difference of only the monthly salary, right? This is also one of the things which a lot of students, you know, ignore in terms of reading. The difference are given of the monthly salary, and question is about the annual salary. Not a difficult thing, but you know, a lot of students miss this part while reading, okay? Fine guys, by the help of the ratios, we can assume that let the salary of A is 2, let the salary of B is 3, and let the salary of C is, you know, 4, 2, 3, 4 like this, okay? Now what? They have given C minus A is 5,000 in real, but C minus A in assumption is how much? C is 4, A is 2, so obviously in the assumption, the difference of C and A is 2, alright? But guys, in the real, that difference is 5,000, okay? So 2 of the assumption is 5,000 of the real. That means one of the assumption is 2,500 of the real, okay? One of the assumption is 2,500 of the real. Now coming to the question part, they were asking the salary of B. So B is 3 in the assumption, right? So 1 is 2,500, that means 3 has to be, you know, 2,500 into 3. See, 1 is 2,500, 3 is obviously 3 into 2,500, and that should be 7,500. All right. But this is the monthly salary of B. Do not forget this part. I'm saying is again, this is the monthly salary of B, and question is the annual salary of B, right? It's not difficult. It's just about, remembering this part. So annual salary of B is what, guys? See, in a month, obviously we have 12 months, right? So we'll be multiplying 12 to the monthly salary. Okay, monthly salary is 7,500, and we'll multiply this by 12. How much it should be? 12 0 0, 12 5 is 60, carry is 6, 12 7 is 84, and 6 is 90. That has to be 90,000. So we can say yes, the annual salary of B is being 90,000. All right. Okay, guys. So this is all for this particular video. I hope you enjoyed. Right. I hope you got to learn something. In the next video, I'll be discussing more word problems, more properties of ratio, more concept based on ratio, and a lot of important applications. So this is all for the day. Thank you so much, guys. Take care. Bye bye.